This question comes from Lily, who asks, what if stars never died? At first, it sounds like a dream, an eternal night sky that never changes. But the consequences are much stranger and much bigger than just prettier stargazing.
Stars die in spectacular ways. Some explode as supernovae, scattering elements across space. Others slowly shed their outer layers, forming beautiful planetary nebulae, leaving behind dense remnants like white dwarfs, neutron stars, or black holes. If stars never died, none of this would happen.
The first thing you'd notice is the lack of new material. Elements heavier than hydrogen and helium, carbon, oxygen, iron, gold, are mostly formed in dying stars. Without supernovae or stellar winds, the universe would eventually run out of the building blocks for planets, moons, and even life itself.
The Earth, as we know it, might never have existed, because elements essential for life wouldn't have been recycled.
Galaxies would look different too. A large fraction of the light we see in the night sky comes from dying stars and stellar remnants.
If stars never died, there would be no supernovae to illuminate nebulae, no pulsars blinking across the galaxy. The universe would feel more static, less dynamic, a frozen gallery of shining stars.
But there's another side. Gravity. When massive stars die, they leave behind neutron stars, or black holes. These remnants shape galaxies, triggering star formation in clouds of gas. Without stellar death, many star-forming regions might collapse, leaving galaxies with fewer new stars over time. Ironically, eternal stars could lead to a universe that becomes slowly stagnant.
Think about our own sun. In a universe where stars never die, the sun would never expand into a red giant. No planetary destruction, no dramatic changes for Earth. That sounds good, right?
But here's the catch. Stars are powered by nuclear fusion, and fusion gradually converts hydrogen to helium. If fusion could continue indefinitely, stars would keep burning steadily. But in reality, the fusion process is what eventually causes a star to die. So never dying implies either an infinite hydrogen supply or some kind of miraculous energy management. If stars never ran out of fuel, the night sky would stay the same for billions of years. No supernova warnings, no stellar explosions. Astronomers would never witness cosmic fireworks. The universe would lack the dramatic cycle of creation and destruction that drives evolution on a cosmic scale.
On a smaller scale, life on planets might face subtle consequences. Supernovae and stellar winds enrich space with elements that help form new planets with water, atmospheres, and the chemicals for life.
Without star deaths, the supply of these elements would be severely limited. Life might still form around older stars, but it would be far less diverse, and complex chemistry would be rarer. Another consequence involves black holes. They form from the remnants of dead stars, but in a universe with eternal stars, there would be far fewer black holes. Supermassive black holes at galactic centers might still exist, but smaller stellar mass black holes would be almost non-existent. This would change the dynamics of galaxies, making them less chaotic and more uniform. Beautiful, but arguably less interesting. And don't forget about energy recycling in the universe. When stars die, they return energy to the surrounding gas, triggering new star formation. If that doesn't happen, interstellar gas clouds might slowly cool and collapse into dark, dense regions, eventually making star formation impossible in those areas. The universe might look luminous, but lifeless. So, if stars never died, we'd have a static universe full of shining suns. No explosions, no creation of new elements, no dramatic cosmic changes. Galaxies would age without evolving, and the chemistry that makes planets and life possible would slowly stall.
beautiful, eternal, and strangely lifeless.
In the end, the death of stars isn't just an ending, it's a beginning. Without stellar death, the universe might shine forever, but life as we know it might never exist. Sometimes, the impermanence of stars is what makes the cosmos truly alive.